can anyone tell me what is the difference between a minor, a major, and a full garbage collection on iOS? Anybody? Good. Garbage collection does not exist on iOS. Trick question. Questions about memory management are some of the most frequently missed questions in an iOS interview. So today, I'll reinforce your knowledge on this critical subject, so at the next interview, you can answer and even ask these questions better. At the start of an interview, your first question will probably be a high level of how is memory management handled on iOS, because it's not garbage collection. You just saw that. For this question, you need to mention how iOS uses a system called ARC, or automatic reference counting, which helps you manage memory by keeping track of all of the code that references each instance of code. So you have one instance, it keeps track of how many other pieces are pointing to it. And this count, this reference count, when it reaches 0, that means nothing else in your code is using your object. So ARC will deallocate it for you automatically. That's the A. The only thing that you have to do is make sure that you're writing code that doesn't form retain cycles. As a refresher, a retain cycle is when you have two objects, they reference each other, and they reference each other in a strong way. Knowing that you have two options for this type of reference, you can reference an object weakly or strongly. And you have a problem, you have a memory leak, when you have the two objects referencing each other with strong references. And that's what we want to avoid. So this is a great way to start off with an answer to the high-level question. But in an interview, that's not going to stop there. Someone's going to say, okay, cool, you read the blog article, but how does this actually work under the hood? Here is where you want to be able to explain how the counting happens. So let's say you have a class, and you instantiate this class inside of a parent class. Automatically, you start with a reference count of 1, because the parent class has a strong reference to this new class. Somewhere else in your code, you reference this object as well. You reference it strongly, so this brings our reference count from 1 to 2. Yet again, you make another reference to this instance, but this time it's a weak reference. And your reference count does not change. It's important to note that this reference count is only changed when it comes to strong references. So at this point, let's say we lose one strong reference, we're back down to 1, and your parent object is deallocated. We're at 0. This is where ARC swoops in, says no one is referencing this code, so let's deallocate it, let's give the memory back to the system, and the app continues to function. It's a really easy concept, but if you're asked this in an interview, just explain the counting and you can't do it, it's a little bit embarrassing. So it's good to know, it's good to refresh on this. The next question, it's not always about iOS in an interview. Sometimes people will ask you a more global question, like, okay, there's ARC on iOS and there's garbage collection on Android. What's the difference between the two? Why is this important? So 2 things to know, comparing these two. Garbage collection can deallocate objects that are stuck in retain cycles. It's smart enough to know, even though there's a retain cycle, there's no other references so I can deallocate it. ARC, on the other hand, cannot. This is why it's so important that we have to pay attention to our code to avoid the retain cycles. If you have 2 objects stuck in a retain cycle, ARC cannot deallocate it. It'll keep taking up memory just until you kill the application. Second difference, ARC. When you get to that reference count of 0, ARC is a machine. It sees the 0, says, okay, perfect, no one's using it, let's deallocate it right away. Garbage collection, on the other hand, it runs in the background at runtime, and it's very vague on the timing for when it deallocates something. So with garbage collection, It could be deallocated immediately or in 20 minutes. And with that, you run the risk of having unwanted behavior or even crashes if you have an object that should have been deallocated 10 minutes ago, but it's still kind of floating around. So that is a downside to garbage collection. If you can answer these sorts of theoretical questions really well, you may get called back to a more technical interview where you're looking at code at the same time and being asked questions. So let's play a game. And this game is called Does This Code Leak? I'm going to show you some code examples. I hope it's big enough for the back. But think in your head, does it leak or doesn't? It doesn't it? And then we'll talk about why it does or doesn't. First example, we have two classes. We have a teacher class and we have a student class. Does this code leak?
Yes.
Okay, yes, easy one to warm up. Yes, we do have a leak here. We have a retain cycle because our teacher class has a strong reference to our student class, and our student class has a strong reference back to our teacher class. To fix this, we have to take one of the strong references and make it weak. So we can do that in the teacher class if we want. Make the teacher reference student weakly and the student reference the teacher strongly, and we have no more memory leak. Easy peasy. How about this one? Does this code leak? Yes? No?
Yes.
Okay, this one does leak. We also have a retain cycle, but this time, instead of between two classes, it's between a class and a closure. A closure, at its root, is a reference type, so it can have the same sort of retain cycle problem. We have a teacher class with a strong reference to the closure here, because it's a lazy var. And we have a closure who's capturing self, which is a strong reference back to the class with self last name. Again, we want to make one of these references weak. We can do that in the closure by adding weak self. So we're now capturing self weakly. The class still has a strong reference to the closure, but the closure now has a weak reference back to the class, and we have no more memory leak. Too easy? How about some nested closures and RX Swift? Does this code leak?
Yes.
Yes? No? Everyone had a chance to read it? Good? Okay. Yes, this leaks. This leaks because of our placement of weak self. We have an outer closure and we have an inner closure. Here we have the weak self on the inner closure. As a rule of thumb, a general rule for nested closures, we want the weak self on the outermost closure. Mind you, this doesn't work for every nested closure. It really depends on how you're using the nested closures and the context. But as a general rule of thumb, we want to move weak self up to the outermost and fix our memory leak. I encourage you to read more on the nuances of nested closures and memory leak. I found a lot doing research for this talk. But remember, keep this in mind as the first step. Move it to the outside. Okay, last example for you. Does this code leak? No? Callum's saying no. Okay, this does not leak. The question is why? Because we have a closure, we have a strong reference to self, and we don't have weak self. What's going on? This closure is a non-escaping closure, as opposed to an escaping closure. When we say non-escaping, this means that the closure is going to run immediately in its scope. It's not stored for later. It can't be passed around to different objects or anything. It can't be executed way in the future. So it's safe, entre guillemets, to use this to have a strong reference to self. Its counterpart, though, so you have the non-escaping closure. We usually see escaping closures in our code. The escaping closure, it can leave its scope. It can be stored for later, and it can be executed in the future. A future where maybe itself doesn't exist anymore. Maybe the closure exists, but its class has been deallocated. And it's for that reason, it's for that risk, that we have to use the weak self in this case to make sure that self actually exists first. So, recap. Non-escaping, you can have a strong reference to self. escaping, you must always have weak self, or unowned, but I speak more to weak self here. Okay, so that was the last example I had. I could go on for days on examples for memory leaks, but I hope you at least learned something a bit new, maybe have something you want to go research later, and I hope you're a bit more comfortable in the next interview, either answering or asking questions on memory management. But these are not the only questions that we get wrong in an iOS interview. So I have a little challenge. For someone who has not spoken before at Cocoaheads, I challenge you to continue this series for interview questions that we struggle with. So I start with memory leaks, find another question that we struggle with. This is a great way to get started as a speaker for a very short topic, or a very short time on an easy topic. And if you're interested, come chat with me after. I'd be glad to talk to you about what it's like speaking and even help you prepare for the next time. But that is it for me. Thank you so much. If you have questions, you can come find me at the apero after. I find that more fun.